Now, this Inorder non-recursive algorithm for traversal of a binary tree is called using the root of the tree. And as you can see in the algorithm, a stack, an array that would act as a stack has been declared, and there is a variable called top which has been declared as -1 because we are going to implement this stack, and we know that whenever a stack is empty, the top is always initialized to -1 to show that the stack is empty. Flag is a variable that has been taken as 1. Now, this is the tree that we are going to traverse. Over here, 10 is the root of the tree. Now, let us make columns over here so that it would become easier for us to dry run. Now, so when we are calling the when we are calling the algorithm, we will call the algorithm with this node of the tree, in order 10, that is the root of the tree. So at this moment, 10 is the root of the tree. Now, as we enter the algorithm, this is while root not is equals to null. So over here, 10 is not equals to null. So we will enter the while loop, top is equals to top plus 1. Now currently top is -1 because that is where we have initialized the top. So top is equals to top plus 1 means top becomes 0. Now stack top is equals to root. So we push the root onto the stack. So we push 10 onto the stack. Right? So stack 0, that means 0th element of this stack array is 10. Now we should again recap that when we are putting this 10 onto the stack, we are actually putting node 10. Node 10 means this node stores the value, that is 10. It stores the address of the left child of 10 and address of right child of 10. Right? Now next, root is equals to root left. So 10 is the root. So root left means 7. So now the root becomes 7. So we go back to this while loop. Root not is equals to null. So 7, current root is 7. So 7 is not equals to null. So again we enter the while loop. Top is equals to top plus 1. So top, which was 0 over here, becomes 1. Stack top is equals to root. So onto the stack top, 7 is pushed. Root is equals to root left. So we are at 7. So root left is 4. So root becomes 4. Again the while loop starts. Root not equal to null. So over here we have 4. 4 is not equals to null. So it is true. We enter the while loop. Top is equals to top plus 1. So the top value becomes 2. Stack top is equals to root. So this node 4 is pushed onto the stack. Right? Now, root is equals to root left. Now if we look at the tree, left hand side of 4 is null. So when we assign root left to root, 4 left is null. So null is assigned as the value of the root. Correct? Now when the loop runs again, null not equals to null becomes false. So this condition becomes false and we come out of this while loop. Now as we come out of this while loop, we encountered this if condition. If top not equals to -1. So let us look at the current value of top. Current value of top is 2. So it is not equals to -1. It is true. So we will enter the if condition. Root is equals to stack top. So we reassign the stack top to root. We reassign the stack top to root. So what is the stack top currently? Stack top is 4 because that was the last node that we had pushed onto the stack. And we know according to the rule of stack, stack is LIFO, last in first out. So the last node that was pushed onto the stack is 4. So 4 will be assigned as the current value of the root. So root becomes node 4 again, right? So we have already popped up this. Now next line, visit root data. So visit, as we know that traversal, in traversal visit means any work we want to do on the node. So for us visit will be to display the value of the node. So we would be displaying the value, we will be displaying the value of the root, that is 4. We will display the value of the current root, that is 4. Now after the value has been displayed, top is equals to top minus 1. Now the current value of top is 2. So when we make top is equals to top minus 1, the value of top becomes 1. Now root is equals to root right. Now you see, basically if you understand the basic concept of Inorder, Inorder means LVR. Now we have already traversed the left side of the root. Left side of 4 has already been traversed. Now we have visited the root, that means we have displayed the value of 4, and now we have to move to the right because LV is done. Now we have to move to the right. So root is equals to root right. So we have to go to the right hand side of 4. Now when we look at the right hand side of 4, right hand side of 4 is also null, right? So the root value becomes null over here. Clear? So now this if condition is done. Since this if condition is done, this else part will not get executed, and we will come to this exit while flag. Now flag value has not been changed inside this loop, so flag is still 1. So we will go back and we will again start with our while loop. While root not equals to null. Now if you look at the current value of root over here, the current value of root over here is null. So therefore this condition becomes false and we don't enter the while loop. We come to the if condition. If top not equals to minus 1. If we look at our chart, the current value of top is 1. So top not equals to minus 1 is true. We will enter the if condition. Root is equals to stack top. So again stack top is assigned to the root. Now which is the current stack top? Current stack top is this one, because top value is 1 and stack top has the node 7. So when the statement is executed, root is equals to stack top, so the root value becomes node 7, right? Visit root data. So 7 is visited. Now top is equals to top minus 1. So top value is 1 over here. So when you make top is equals to top minus 1, top value becomes 0. Right? Root is equals to root right. Again, if you look at the tree, we have traversed the left side of 7. We have visited 7. We have already printed it. Now we have to move to the right. So root is equals to root right. Now what is there on the right hand side of 7? Right hand side of 7 has 5. So when we assign root right to root, that means the current value of root becomes 5. Correct? Now again we are done with this if condition. Else part will not get executed. We will come to the exit while. Now in this exit while, flag is still 1. So again we will start off with our do loop, inside which we have this while loop. while root not is equals to null. Now what is the current value of root? 5. So current value of root is 5, which is not equals to null. So again we will enter the loop. Top is equals to top plus 1. Top value at this moment is 0. So top plus 1 means top value becomes 1 again. Stack top is equals to root. So onto the stack top, root is pushed. What is the current value of root? 5. So node 5 is pushed onto the stack top. Root is equals to root left. So you see we have to go to the left hand side of 5. Left hand side of 5 is null. So null gets assigned to the value of root. Now as we start off with the while loop again, while root not equals to null, but current value of root is null, so this while condition does not work. We come out of the while loop. If is encountered, if top not equals to -1, looking at the top value is 1, so obviously it is not equals to -1, so we enter the if condition. Root is equals to stack top. Now what is there at the stack top? At the stack top we have the node 5. So this node 5 again gets reassigned as the value of the root. And we will visit the root data. So 5 is visited. Top is equals to top -1. So top value becomes 0 again. Root is equals to root right. Now we go to the right hand side of 5. So what is there on the right hand side of 5? Right hand side of 5 has null. So again the root value becomes null. If condition done, else part will not get executed. While flag is still 1. So again we start off with our do loop, while root not equals to null. Now let's look at the current value of root. Current value of root is null. So this condition becomes false and we do not enter the while loop. We straight away come to the if condition. If top not equals to -1. What is the value of top? Top value is 0, which is not equals to -1. It is true. So we will enter the if condition. Root is equals to stack top. Now, what is the value of top? The top value is 0. And what is there at stack 0? If we go back, we will see stack 0, that is the 0th element of the stack that we had pushed at the first, was the root node 10. So now again, when we are assigning stack top to root, so root is becoming 10 again. Right? Now visit root data. So 10 will get visited. Top is equals to top -1. So top value was 0. So top becomes -1. That means our stack becomes empty. Root is equals to root right. Now again I will show you the tree. 4, 7, 5, the whole of left child of 10 has been traversed. Then we have visited the 10. So LV for the node 10 is done. Now we have to move to the right hand side of 10. So you see we execute over here, root is equals to root right. So over here the root becomes 10 right, that is 6. Right? Now again, since this if condition has been executed, else part does not work. While flag is still 1, so it is true. We go back, we enter the do loop. While root not equals to null, root value is 6, so it is not equals to null. We enter the while loop. Top is equals to top plus 1. So the top value becomes 0. And stack top is equals to root. So stack top becomes node 6. And we move to the left hand side of the root. Root is equals to root left. Now what is there on the left hand side of 6? Null. So this is null. Now when we go back to the while loop does not work because the condition is false. We come to this if condition, top not equals to -1, top value is 0, so it is not equals to -1. So we enter the if condition, root is equals to stack top. So root becomes stack top, that is 6 again. Visit root data. So as we visit root data, that means we visit the value 6. Top is equals to top -1, so top becomes -1 again. Root is equals to root right. So now we move to the right hand side of 6, which is 9. So root becomes 9 now. Correct? Now, again else part does not work. While flag, we go back to the do loop. We enter while root not equals to null. Root value is 9, so it is not equals to null. We enter the while condition, top is equals to top plus 1. So top, which was -1 over here, again becomes 0. Stack top is equals to root, so node 9 is pushed onto the stack. Root is equals to root left, so we move on to the left hand side of 9. Now what is there on the left hand side of 9? Left hand side of 9 is null. So null is the new root. So again we go back to the while condition. While root not equals to null, it becomes false. So we come to the if condition. If top not equals to -1, what is the value of top? Value of top is 0. It is not equals to -1. So we will enter the if condition. Root is equals to stack top. So again 9 is assigned as the value of the root and this is popped out. Visit root data. So 9 gets visited. Top is equals to top -1. So top becomes -1. Root is equals to root right. We move to the right hand side of 9. So what is there in the right hand side of 9? Right hand side of 9 is null. So null gets assigned to root. So now this else part does not work. We come over here. Now flag has not changed. So again the do loop starts. Now let us look at it very carefully. Do loop starts. While root not equals to null. What is the value of root now? Null. So this is false. Condition is false. So we do not enter the while loop. We come to the if condition. If top not equals to -1. But what is the value of top over here? Top is -1. So this condition also becomes false. So as a result, since this if condition becomes false, we come to this else part. And in this else part, the flag is set to 0. Now, when we come to this while exit while, now while flag, that means while 0. So while 0 is always false. So now this exit condition also becomes false and as a result the loop stops. So therefore this is the result that we get from our inorder traversal. And how do we implement the algorithm of inorder traversal? The non-recursive inorder traversal algorithm is implemented with the help of a stack. We implement a stack and using the stack we have created the inorder non-recursive algorithm for binary tree.